So there are two possible elimination mechanisms, and here they are. You should always remember that E1 competes with SN1 and E2, which competes with SN2. Keep that in mind. So let's begin with E2. E2 stands for elimination, and the 2 stands for bimolecular, which means that you have two species at the transition state colliding or getting near each other. This type of elimination is dominant reaction of tertiary alkyl halides in the presence of strong base, and it competes with SN2 for secondary and primary alkyl halides. So if it's tertiary, you don't have to worry about SN2. It's just going to be E2 as long as you have a strong base. But if it's secondary and primary, then you actually have to take into account that it's competing with an SN2 reaction. So let's take a look here. What we have in the reaction is we have a base, if we put the lone pairs, and of course we have the alkyl halide. The outcome of this reaction would be the following. Plus CH3, CH2, OH, and of course, the bromine as the leaving group. Now, you see how mechanisms are important, because if we didn't have mechanisms, we would be struggling to understand how this process took place. Once again, let's identify our alpha carbon. It's right here. Let's identify our beta hydrogen. It's this one, but of course, all of these have beta hydrogens. So yes, it won't matter which one we pick. It will in a few videos. But now, of course, all of these would be beta carbons, and this would be the beta hydrogen. That's a beta carbon. So maybe you can work out the mechanism before we get to that. If you want to work it out before we get to here, you may do that, but you may pause and look at it. But here's the mechanism. It's a concerted, meaning it's only one step. And again, I'm going to put those lone pairs on the base. Once again, I will make my beta hydrogen mark it, and that is my alpha carbon. So here's the mechanism. Mechanism is the following. In order for H to be eliminated, it has to be removed. So this lone pair in an acid-base reaction forms a bond with the H. Remember, H can't form more than one bond. So the electrons, you might be thinking they go back to the CH2, but that wouldn't make it a one step. That would make it multiple steps. So what happens instead is that those electrons shift and of course form a double bond. But again, that carbon cannot have more than 4 bonds, so it has to break and they go to the Br, those electrons. So therefore, our product is CH2. Here's a double bond, CH3 and CH3. As I said, we have the conjugate acid of the base. Of course, we have Br minus, and you can put the lone pairs on it, of course. Now, I will mark the beta hydrogen for you. Here it is. Here's your original alpha carbon, although this is unorthodox that we put it here, but still, just to show you, give you a frame of reference. So you're forming a double bond. What you should be aware is that kinetics, the kinetics of E2 is that it's a second order reaction, as we said above, that this is 2 species at the transition state. So again, you double one, you double the rate, you double both, you quadruple the rate, etc. So this is, again, look how it's a base in SN2. It was the rate equals K of the alkyl halide. Notice the difference in the nucleophile. So now we call it a base here rather than a nucleophile, because it is a base. This is not a nucleophile. Let's talk about the energy diagram really quick. The energy diagram is similar to an SN2 reaction. So one step. Once again, here's the difference between the energy of the reactants and the transition state. So let's mark some things here. Here's the transition state right here. And of course, here you have delta H. So the products are stable. So these are your reactants. These are your products. We're interested in the transition state. So the transition state looks like this. And you're going to need lots of space to draw this. So we will copy this again here. We had a CH2. Okay. So kind of copying here some parts of that. All right. So watch how we draw this. This bond is forming. Obviously, this is breaking. I don't want to use too many arrows. This one is a double bond is forming right here. This arrow going back, and of course the bromine is leaving, so this is breaking. So if I put my CH2, CH3, CH2, O, and the H down here, and the bromine at the top, then my transition state would look like this. This bond is forming. This bond is breaking. This bond is forming. and this bond is breaking. Let me make this a little bit more clear. Of course, this would be delta minus. This would be delta minus where the electrons are coming from. So this is your transition state. Forming, breaking, forming, breaking.